This is 3.2, using algebraic methods to solve linear systems. Part 1 is writing and solving systems of equations by using the algebraic method called substitution. To solve a system of linear equations using what we call substitution, you solve one equation for one variable and then substitute that expression into the other equation. Now, an important key point to remember is that here we are looking for an x and a y value. So our final answers will be written in a coordinate point form. So keep that in mind as we go through these. To look at our first example, we are told that x equals 4. Well, if we know x equals 4, we should be able to substitute that in for x, and then that can help us find y. Here's what I mean. If x equals 4, I'm going to say, all right, that means 2 times 4 plus 5y should equal 18. Now we just have to solve for y. We know x equals 4. We're using that to solve for y. 8 plus 5y equals 18. Subtract 8. 5y equals 10. Divide everything by 5. Y equals 2. X equals 4. Y equals 2, so our final answer is 4, comma 2. Remember, the x comes first, the y comes second. So that means these two lines, since these are linear, these two lines intersect at the point 4, 2. Let's try one using expressions instead. All right, so number 2, 6 minus y equals 2x, and y equals 8x plus 1. Well, y equals 8x plus 1, so I'm going to take that 8x plus 1 and substitute it in for y here. So 6 minus 8x plus 1 equals 2x. The key to know if you've substituted right is to see, is there only one variable to solve for now? And yes, there is. And you can see this 8x plus 1 replaced the y. All right, from here, solve for x. So I'm going to distribute that negative. 6 minus 8x minus 1 equals 2x. 6 minus 1 is 5. Add 8x to both sides. So you get 5 equals 10x. Divide everything by 10. You get x equals 5/10, which if you reduce that is 1/2. So I get x equals 1/2. But remember, we aren't done. Once we found x, we still need to find y. So I know x equals 1/2, so I'm going to now solve for y. You can put x into either equation. I'm going to use y equals 8x plus 1 because the y is already solved for. So y equals 8x, 8 times 1/2 plus 1. Y equals half of 8 is 4 plus 1. So y equals 5. So y equals 5, x equals 1/2. So x is 1/2, y is 5. Our final answer is 1/2 5. All right, number 3. Now, equations that look like this are kind of nice because they both are equal to y. So since both of these are equal to y, we just have to set them equal to each other. So we are going to take 3.5x minus 20 and set it equal to negative 2.5x plus 34. Now that we've done that, get all of your x's on one side. So I'm going to add 2.5x to both sides. So I get 6x minus 20 equals 34. Add 20 to both sides. 6x equals 54. Divide everything by 6. X equals 9. A lot of times it's tempting to stop there. We only have x. We need y because remember, everything needs to be in a coordinate point, x comma y. Y equals 3.5x minus 20. or y equals negative 2.5x plus 34. You can take that 9 and put it into either one. I'm going to choose to put it into this one right here. Y equals 3.5 times 9 minus 20. 3.5 times 9 is 31.5 minus 20 is 11.5. So y equals 11.5. So now we have a y value and an x value. So our final answer, where these two lines intersect, is at the coordinate point 9, 11.5. Now for these next two problems, it's going to be helpful to remember from 3.1, we saw a couple of examples, right? If we have two lines that intersect, we get one solution, just x, y. If we have two lines that are parallel, that means they don't intersect, so we have no solution. If we have two equations that are the same, we have infinite solutions. All right, so it's going to be helpful to remember that as we look at number 4 and 5. You're going to want to make sure you have these diagrams for your reference purposes. All right, so let's start here. Number 4, y equals 2x minus 5. We're going to put that expression in for y into the other equation. So 4x minus 2 times 2x minus 5 equals 10. So just so you can see, there's that y value I plugged in. Distribute that negative 2. Be careful with your negatives. So 4x minus 4x plus 10 equals 10. All right, now this is where I was telling you we want to keep in mind what these things all mean. So 4x minus 4x is 0x. So we're left with 10 equals 10. All right, now that's a little weird. We didn't solve for x. We don't know what y equals. We don't know what x equals. So what's going on here? This is an example. We got the same number on the left and the right. So that means we have infinite solutions. If we were to rearrange these equations to both be in slope-intercept, we would see that they're both 2x minus 5. So let's do that. Let's take this 4x minus 2y equals 10 and put it in slope-intercept form and see if it matches this one. So we get negative 2y equals negative 4x plus 10. Just subtracted the 4x from both sides. Divide everything by a negative 2. So we get y equals 2x minus 5. You can see those are the same equation, which will make the same line. So we just have one line there that's being graphed. So there's infinite solutions. So the important thing to remember, if we're doing this algebraically and not graphically, you can't see that they're the same line. So if you get the same number, if you get a true statement, if you get a constant equals a constant, right? Two numbers that are the same, that's going to be infinite solutions. All right, let's look at number 5. X equals y plus 6. So we're going to plug that expression in for x into the other equation. So 2 times y plus 6 minus 2y equals negative 6. Distribute the 2. 2y plus 12 minus 2y equals negative 6. So you can see here 2y minus 2y is 0y's. So we're left with 12 equals negative 6. Here we have something that's not true. We have two numbers that are not equal. Well, if getting an x and a y meant one solution, getting two numbers that were the same meant infinite, now we're looking at no solution. So for no solution, if you get two numbers that are not the same, like A doesn't equal B, we have no solution. So these would be parallel lines. And if we put these both into slope-intercept form, you will see that they end up having the same slope. For example, this first equation is, if we subtract 6 from both sides, we get y by itself, x minus 6. Here for this equation, if we subtract 2x from both sides, we get negative 2y equals negative 2x minus 6. Divide everything by negative 2, you get y equals 1x plus 3. So you can see they're different equations, but they have the same slope. They both have a slope of 1. So they're never going to intersect, therefore no solution. So make sure you have these diagrams written down. All right, number 6. Cable television provider A has a $60 setup fee and charges $80 per month. We have another provider B that has a $160 equipment fee, which is kind of the same as setup fee, and charges $70 per month. And how many months will the cost be the same? What will that cost be? All right, so when will you have basically spent the same amount on cable for each of these? All right, so let's look at what we have going on here. So cable provider A has a $60 setup fee plus $80 per month. So the X represents month and Y represents total cost, okay? Total that you've spent. All right, and then cable provider B has a $160 equipment setup fee plus $70 per month. So it's more to join, but it's a little less per month, which is kind of nice. So now we want to figure out how many months will these costs have matched. Well, in order to find that, we have to figure out when they're the same. So when are these two equations equal to each other? So 60 plus 80x equals 160 plus 70x. And we're going to solve for x because that will tell us how many months have passed. So subtract 70x from both sides. 60 plus 10x equals 160. Subtract 60. 10x equals 100. If we divide everything by 10, we get x equals 10 months. All right, so in 10 months, you will have spent the same amount on both companies. Now they're asking, what will that cost be? So there's two questions. Two questions they're asking. How many months? X. What will that cost be? Y. So now we need to figure out what Y is. So we can use either of the equations. We just know X is 10. So I'm going to use this first one here. So Y equals 60 plus 80 times 10. So in 10 months, you will have spent 60 plus 800, so $860 on cable. All right. Now, after that, one of them you're going to end up spending more on, one of them you're going to end up spending less on. You can graph them so you can see how those line up after that 10th month to see who you want to stay with, maybe. All right, next, number 7. So this one has a little bit more going on with it. So let's read it. A high school group is planning a 5-hour outing at the community park for elementary aged kids. The park rents bicycles for $8 per hour and inline skates for $6 per hour. The total budget per person is $34. How many hours should students spend doing each activity? So our hint here, or our key, is how many hours should students spend doing each activity. So they're going to be spending a certain number of hours biking and a certain number of hours skating. So we're going to look at Okay, one of our variables, let's call it x, is going to be number of hours biking. All right, and then our second variable, y, will be number of hours skating. All right, so now let's see how we can combine those so we have two equations. So we have a system that we can compare here. So first, let's take a look at the number of hours we're going to be out. They're doing a 5-hour outing. So that means the number of hours biking and the number of hours skating can only add up to 5 hours. All right, that's good. So number of hours biking, x, plus number of hours skating, y, has to equal 5. No more, no less. All right, now we have a cost. The budget is $34 per person. All right, so $34 per person. So that $8 per hour biking and $6 per hour inline skating have to add up to $34. So $8 per hour biking, so 8x, plus $6 per hour skating, 6y, equals 34. So total number of hours doing each is 5. The cost for each has to add up to 34. All right, from here, we need to find what x and y are. All right, well, in our previous examples, it's been kind of nice. Either both were equal to y or one of the variables was already solved for. So what we're going to do here is we have to solve for one. So this equation right here, since the coefficients are just 1, I'm going to solve for y. So subtract x, so I get y equals 5 minus x. All right, then what I do is take that y and put it into my other equation. So 8x plus 6 times 5 minus x equals 34. Distribute the 6, 8x plus 30 minus 6x equals 34. And from here, solve our equation. 8x minus 6x is 2x plus 30 equals 34. Subtract 30 from both sides. So 2x equals, whoops, that's supposed to be a 30, equals 4. So when you divide by 2, you get x equals 2. So x equals 2, it means essentially we should be able to spend 2 hours, or each kid can spend 2 hours biking. All right, but they want to know how many hours we can spend doing each activity. Well, if they can spend 2 hours biking, let's look at what y would be equal to then, what the number of hours skating would be equal to. So if x equals 2, y equals 5 minus that. Y equals 5 minus 2. So y equals 3. So that means they can spend 3 hours skating. So 2 hours biking and 3 hours skating. Well, that adds up to 5 hours. And that should also fit $8 per hour on bikes, $6 per hour using skates. So each kid, to fill up their 5 hours, can do the activities that long. All right, so you've seen two different types of setting up systems, and you've seen the 3 different types of solutions we can have and what they would look like either by graphing from 3.1 or from solving using substitution. If you have questions, ask your teacher. Otherwise, do your practice. Thank you.